So, good evening to the people I already know who've already had me in their house doing insulation. It's a delight and a surprise that you've come back for yet more of me droning on about the extreme advantages of insulating your house. So, key messages for tonight. These are the things I want you to have in mind and take away. It's urgently needed. There are so many drivers, there are so many reasons why we've really got to get on with insulating our houses, in fact, all buildings. It's technically possible. We've got all the technology, we've had it for decades, and it's entirely doable. One of the biggest barriers, though, is the skills shortage. And this is both in terms of new entrants to the construction industry, but also a huge retraining program is needed for existing tradespeople. And part of that challenge is that how do you teach old dogs new tricks? Well, I think you just need a bigger bone, and you've got to get them excited about a new market with high spec. But there's a lot of benefits for doing it, and I'm going to, in a later slide, I'm going to describe why it's such a really, really good reason for doing this work. But we're going to need some government policy change because we need a lot of money. We also need much higher design targets and build quality. But we can start with our own houses and highlight the benefits to our friends, and of course tell our local councillors and our MPs. So, what's possible? This is a house of a very good friend of mine in Otley, and the photo show here is this icy stripe down the outside of his house. Now, in fact, the whole street was covered in hoarfrost. It's a few years ago. Very pretty it was too. And after a few days, this hoarfrost on the outside of the majority of houses melted, but it didn't on Rod's house because it wasn't leaking heat, and that was because it insulated it. And this is a really dramatic indicator that all the other houses are leaking heat. So Rod's house is amazing. So it's warm and comfy all the year round, and he's got a wood burning stove, but he hardly uses it. You can go in his house and the heating hasn't been on for days and it's still warm. The lighting is all ultra bright LED, run off a 12-volt leisure battery and charged from a very small solar panel out the back of his house. The gas was turned off 20 years ago, and his mains electricity bill for the whole of 1 year that he showed me was about £40. Now, I'm really excited by the possibility that a 100-year-old terrace house can be made to be this self-sufficient. If we could do that with the majority of houses, that would make a huge difference. My journey to here, I started a community group in Otley, 2008. Then I went on to make a insulation company, was part of writing the home insulation manual. I work with Leeds Beckett University. This is me and Chris Gorse reviewing some plans of a house that we're doing monitoring in. I do talks in various places. This was at the Harrogate Home Building and Renovation Show. I'm giving some advice at an earthship down in the south of England. Last year, I was actually an expert witness to the Leeds Citizens Jury, where I was talking about wide-scale community-led insulation schemes in Leeds. And during the lockdown, I've given some of my time to a food delivery charity, so driving that van around Yorkshire. What's the climate doing? Well, September this year was the hottest ever. Atmospheric carbon is doing this, and the temperature is doing that. This red bar is the same time scale as this graph, so you can see the two are in line. Here's the source of that information. Extreme weather events are happening more frequently. We'll all be very aware of the dreadful fires in America. And in fact, this year in the Gulf of Mexico was the first time ever there's been 2 hurricanes at the same time, and that's quite significant and a real indicator of the warming waters creating all that energy. We don't have to go far though to see huge effects. English Lake District, Saddleworth Moor, you'll remember this being on fire. And one thing that wasn't publicised very much was last year the Amsterdam tornado.
Kijk, kijk, hij raakt de grond bijna. Hij raakt bijna de grond. Kijk, 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 hij raakt, kijk, daar gaat hij. Jezus, kijk dan, daar is een tornadootje. Moet je zien? What the fuck? Ja, een tornado.
Holy shit!
What the fuck?
Nee!
Ja.
Oh, was er naar binnen fietsen! Oh! Oh nee! Oh! Wat erg!
What the fuck? Wat heb ik?
Now, I don't know about you, but that's getting a bit close. I always thought tornadoes happened in Texas or somewhere, but Amsterdam really isn't very far away. One of the other huge drivers for me to be part of this work is the fuel poverty in the UK, which I think is a criminal effect of poor policies. And in fact, even with the most recently massaged figures, 2.5 million households in the UK are living in a place where they have to choose between heating or eating. That's actually 10.3 of the whole population. 18% in older houses, 21% in private rented properties, and that's utterly staggering, criminal, 23% of lone parents with children. Last week I was giving this talk, or a similar one, to a community group in the Scottish borders. So I looked up the figures in Scotland, and I was horrified to find the lowest fuel poverty there is in Edinburgh, and the highest is nearly 60%. That's really very bad. So if we didn't need any more positive proof that global warming is happening, we only have to look at certain items of clothing, which tells its own story. So what can be achieved? I've just drawn a very simple bar graph here. The one on the left, the average figure, about 15,000 kilowatt hours combined gas and electricity for the average house. At this end down here, the passive house is about a tenth that, 1,500 kilowatt hours a year. A new build is still pretty bad. They're just not meeting the standards. Underfloor is a kind of a diluted passive house version, but very expensive because all the components have to have certificates. So super installation, a kind of a term where we're going well beyond building regs, but really making a big effort to improve air tightness and putting insulation on our external surfaces is a good target, I feel. So why is it a good idea? Well, the whole thing would create tens of thousands of jobs, hundreds of thousands. It would certainly stimulate the manufacturing industry and the supply chain. The health and well-being of millions of people would be affected, and of course that reduces the burden on our precious NHS. It builds community involvement. Once you've got people working together, they all start to pull their stocks up, and of course if they're not paying huge fuel bills, they are putting money in the local economy. Absolutely, it would reduce carbon emissions, and in fact it would improve UK's fuel security because we wouldn't have to import as much gas and electricity. Now hang on, if it's such a good thing, if there are so many co-benefits, why is it not one of the biggest national infrastructure priorities that we have? And you could choose your own capital project that we could do without to give us insulation for the whole of Britain. Now, government policy we need to change. We need something like £200 billion to fix all of this, which sounds like a lot of money, but they seem to find it. If one of their mates has got an airline who's going broke or a bank is about to crash, they just seem to print it. So writetothem.com is an easy way to send a message to your local councillor or your local MP. Heat loss from a building, there's several ways that it comes out. Through the floor is often a forgotten one. Typical.
Oh, yeah.
Could we have people turning off their microphones, perhaps? Thank you. With a stone built property, this figure through the walls would be about 45%. Okay, I'm going to explain U values, and the reason that I want to do this is because every discussion about what you have now and what you could have is based on this simple number. It's a term which describes the amount of heat which is flowing through a surface. It applies to any surface. So let's just take this 1 square meter of wall. We're going to say it's got a U value of 5. There's a temperature difference of 1 degree C inside to outside. That 5 means that 5 watts of energy is permanently flowing through that 1 square meter. If we go up to 20 degrees C, a more typical room temperature, then we're now up to 100 watts through that 1 square meter. If we take a more typical area of an external wall, let's say it's 10 square meters, again with room temperature, we're now up to 1,000 watts of energy, 1 kilowatt. Now, there will be losses through the other surfaces in that room, the floor, the party walls, and the ceiling. But whilst we're sitting in this room, we have to pour 1,000 watts of energy into that room, or else that temperature will fall. And I bet you've all been in houses where you can get the room warm, but the moment you turn the heat off, the temperature plummets. So a fire like this, I imagine there are people on the call who can remember these. I grew up with this kind of heater in the corner of the room trying to warm it up. Okay, well, let's put some insulation on the wall. Let's try 100 millimeters of Kingspan, often called PIR. The U value would drop to 0.25, and that means there'd only be 0.25 watts flowing through that surface. For the 20 degrees C room temperature case, we're now up to only 5 watts, and for the larger wall here at room temperature, we're up to only 50 watts. Now 50 watts, a human being gives off about 50 watts when they're sitting still, or 3 cats. So you could say we either need more insulation or more cats. Now, this kind of fire, I mean, I can't believe anybody still uses this kind of fire. Well, here's the funny thing. In a newspaper, only a couple of years ago, there was this picture of the Queen meeting some dignitaries. What is she heating her room with, surrounded by millions of pounds worth of paintings? Well, it's a fire like that. Okay, so let's give you a framework of, this is important because this is how we describe what's possible in each house. Stone built house, somewhere between 4 and 10, brick built 1.5 to 5. The golden standard here is the U value, sorry, the U value of 0.1. If we can get down towards that, then your house is going to self-heat. What builders would typically do is put cavity wall insulation in, which is pretty bad, or just 50 millimeters of PIR, Kingspan, which is also not close to our ambitious target. 200 millimeters of mineral wool or polystyrene or 100 millimeters of Kingspan gives us a U value in this kind of area. Or if you want to get more ambitious, then PIR at 150 millimeters comes to here. The only other material that can challenge Kingspan as a rigid board insulant is aerogel, but it's 10 times the price, so it's not really available as a domestic product. Single glazed window is 5, double glazed window with air 2.6 to 2.9, argon filled double glaze is twice as good, argon filled triple glaze twice as good again. Now some of you will perhaps have leaded lights in your rooms or above the door, but the lead is so conductive that a typical stained glass window, leaded light window, has got a U value of over 100. So it's practically thermally transparent, heat just blowing out into LS6. And for comparison, here are some figures for metals, which are wonderfully conductive. What can be done? Well, this is a manual that I worked on with Leader, and Matthew is with us today from Leader, and he helped with this. And this is I'll let some of these pages slide on as I'm talking about this. This is a guidance manual of how to retrofit particular aspects of your home. And this is available for each of you to download. It's as a PDF. It's available for anybody to download. I'll give you the link. And this gives you some of the ideas about what you can do in particular places. These are some of the housing associations and housing co-ops that I've worked with in Leeds, and they're using this manual pretty much on a daily basis. This is worth having a look at. It's a blog by a friend of mine, insulatingmyhouse.wordpress.com. I'll leave it to your imagination what the blog is about. And here's a link for the super insulation guidance manual. If you just drop me an email, I'll send you a link to download it. Okay, so how much is enough insulation? This is always a good question. Is anything better than nothing? Well, no. If it's cold and you're not wearing enough, you're going to be cold. So what we need is, this is Molly Hughes, who was the first British woman to climb Everest by 2 different routes. And here she is wearing sufficient insulation to keep her warm. And that's the measure. That's how you decide how much is enough. So here's a case study of a house in Armley I did a couple of years ago. This is the room I was working in, upstairs bedroom. It's actually got 3 external walls on it, the gable wall around the corner. Now, this is some of the kingspan. I'm just shaping it here, and it's actually going into this sloping part of the ceiling, which apparently in Cornwall they have the wonderful word skeeling, which I'm now trying to bring into every conversation. Here's a typical view of that room, and we've insulated the outside surface, this wall and these sloping sections with 150 millimeters of kingspan, and this has just been a transformational change to the room. Now, it was so cold that even with the heating full on, they had this hot air heating system. They couldn't use it. They wanted to use it as their main bedroom, but they couldn't use it. And in fact, the work I did blocked up the hot air vent on purpose. Don't worry, I did notice it was there, but it just happened to be where I wanted to put some insulation. And then before they put a central heating radiator in, which was the plan, they made it their main bedroom. And they found that just with 2 people in there and the bedside lights on, the room stayed at a comfortable temperature. In fact, they told me it's now the warmest room in the house. Insulation works. Now, air tightness is crucial. I did have a video to show you here, but I'm not going to play that tonight. This is the floor joist going into the inner leaf of the outer wall. And what's not understood well is that they're sitting in loose sockets here, and there's always cold air blowing in around them. And this tissue paper that I had taped onto the wall was blowing backwards and forwards because of the airflow coming in. And it's really important to deal with this air tightness and this cold air blowing into the center of the house to get a warm home. Okay, underfloor insulation project. This is working under a house in, I can't remember, Headingley. There we are, it's in Headingley. And you've got to have all the gear on, of course, to do this kind of work. What we're doing here is one of the jobs is to seal the gaps between all of the floorboards. There's a lot of air leaks between the boards as they shrink over time, and also around the edges. So bathroom silicone sealant is how we do that. Here's some expanding foam going in around the edges of the room. You find some treasure whilst you're down under these properties. Here's a remarkable old newspaper that we found. I think there were adverts for cars for £300 brand new or something like this. Continue. The other thing you find under floors is meter after meter of bare copper pipe, and this is hemorrhaging heat into the local area. Copper is incredibly conductive, so the outside temperature of these pipes will be exactly the same as the hot water inside them, and that heat is being wasted. Quite often you'll find that where the pipes are going through the floorboards, the people without training have left huge holes, and this is another source of cold air blowing into the house from under the floor. Of course, what we've really got to do is to put a very thick layer of insulation around the pipework to keep the heat in. And of course, one of the advantages of this means that the hot water that you've created in your boiler actually gets delivered to the radiators in your room at about the same temperature that it started. So, of course, your rooms are going to heat up quicker as well. This is a detail showing the silicone on the joints. At the edge of the wall here, I've put some plastic mesh, and I'm going to fill this entire space behind this joist with expanding foam, and that's going to give me both airtightness and insulation. These metal hangers here that you see is part of a suspension system I create, which allows me to put 2 layers of mineral wool below the floor, one between the joist and one below it at right angles, and you can get down to some very low U values by doing that. So we end up with a team of people down here. You measure the insulation out, and then you fit it between the joists, and appropriate PPE is necessary for this. This is actually a powered ventilator. So here's a community insulation project. I've repurposed the term housewarming party to describe how people can come together and work on each other's homes, and I run workshops in people's homes to get the job done. This is a house in York. It's actually one of the founders of York Community Energy. We're going to be working in this downstairs room down here. What we found when the carpet was lifted was that huge gaps in the floorboards and around the edges where lots of cold air blowing in. So we had to lift the floorboards, take out all the nails, either with crowbars and so on, or angle grinders. Here's the team once we've taken all the floorboards out and cleaned all the rubble out from below it. And then once we build this lattice work, this matrix of timber and so on, we feed the mineral wool in to create the 2 layers. So this shows the first layer underneath the joists, and this is the second layer going between the joists. And then finally, we've got the new floor fitted. Now, what this gave us was the old U value of 3.3 down to a new U value of about 0.1. So you can see the heat loss has reduced to about 5% of what it was, and with no drafts. So how's it done? Well, this is a house in Bingley. First of all, we'd strip the plaster from the walls, we'd apply insulation onto the walls, and then plasterboard it and skim it. And you can see our clever plasterer here has recreated the curves around the corners. Cornice and Skirting is a real challenge, but there's companies that I work with that can recreate any molding and reinstate it. In fact, on this photo here, this is original and this is the new. So it's actually, and this is the insulated wall. So you can see it can retain the look and feel. Similarly, actually, with skirting boards, this is a design you can't buy anymore. So I gave a sample to this other company I work with. They created a cutter and we could run off as much length as we needed to recreate the look of the room. And there's the room when it's finished with the 2 urchins now on this much wider window ledge, which has become kind of a window seat, bit of a feature. So appliances, here's before Tony reminds me, I am conscious that I'm coming to the end of the time. This is an experiment I did with my fridge. Fridges are cold to the touch, and that's because the insulation isn't sufficient on the door and the walls. So what I did was to insulate my fridge, and I did a before and after set of measurements of how much energy it used, very accurate meter. I did it over 2 weeks and several times a day, and with this insulation on, it used half the amount of energy. In fact, overnight, when I wasn't opening the door, it didn't use any energy. So one thing we could consider doing is actually just using plastic trays to store our food in the fridge, and therefore all the cold air won't come falling out. Radiator foil, definitely a good idea. LED light bulbs come in all shapes and sizes. Kettle, I like this one. It's got a reservoir. You just put as much as you need to boil. And this one I particularly like. You can actually choose the temperature at which it clicks off. The future is already here. You can get wirelessly controlled radiator valves, which allows you to zone your house by radiator. We can have curtains that are automatically open and closing. I mean, this is 1970s technology. And I really like the idea that by using occupancy detection, motion sensing, we could, as somebody walks in a room, open the curtains and put the heating up. So in other words, we could keep the curtains shut during the day and the heating on low until somebody's actually using the room. Ventilation, we could open the window. That actually works rather well once you've insulated the walls. Trickle vents are really important. Whole house mechanical ventilation. This is where you've got a very sealed exterior envelope, and you're extracting moist, stale air from kitchens and bathrooms and putting fresh, warmed air into living spaces. But it's very hard to do as a retrofit. So what you can do is an individual room mechanical ventilation with heat recovery, and they work very well. Finally, final slide. It is my intention to go up a gear from Sure Insulation to create the company Sure Zero Carbon. And my intention is to do all of this, whole house plans, retrofit coordination. There's some new standards coming out, community workshops, performance monitoring and training. And I'm inviting people to come and join me in this venture. So if you know somebody who wants to come and be part of this, there we go, time up. Thank you. I'm interested to talk to you. Thank you.